All right, this one comes from Superhuman Dose on YouTube. He says, can you touch on classes in your next videos, Dave? There are so many of them. General, inner, nested, sealed, data, abstract, annotations, enums. It's so confusing. Yes, I can. And in fact, in this video, I'm going to provide an overview of all of the different kinds of classes that Kotlin offers, along with some general advice on when to use each one. So let's start with a good old-fashioned regular old class. Like in most general purpose programming languages that support object-oriented programming, in Kotlin, a class bundles together state and operations in the form of properties and functions. So a regular class like this is your default choice for putting together state with operations that act on them. Now in Kotlin, we can declare a class in a lot of different places. So we can put it immediately inside a file, like I'm doing here. And if you want, you can declare more than one class per file. And we can also create a class inside a function. And when we do this, it's known as a local class. And this can be a good idea when it's a helper class that's only relevant to the implementation of that function and wouldn't really be needed anywhere else. You can also declare a class inside another class. And when you do this, it's called a nested class. So to declare a nested class, just put it immediately inside the body of another class like I'm doing here. To construct a nested class, you just get to its constructor by typing the name of the outer class, a dot, and then the name of the nested class like this. Now, a nested class can be a good choice when it's uniquely related to the outer class, or you can make it private, in which case it can work great as a helper class that is unique to the implementation of that class. A nested class can often be a good fit for serializable models. For example, if this example JSON is returned from an API and the metrics object only ever appears within this post resource, then a Kotlin nested class can be a fine choice. Now, by default, a nested class does not have access to the members of the outer class. So to demonstrate this, I've created a class called favorite strings, which has 3 properties, first, second, and third, and I built a custom iterator, and this is certainly overkill, right? Because we could just put these 3 properties into a list and then get that the iterator from the list. But at least here you can see how a regular nested class can't get to the members of the outer class. So if you need it to do that, the nested class will need to be an inner class. And to turn a regular nested class into an inner class, we just add the inner modifier to it like this, and those compiler errors go away. Since an inner class has a reference to its outer class's state, if we want to instantiate it, we have to have an object reference for that outer class. So in other words, when it was a regular nested class, we were able to construct it through the name of the class. But when it's an inner class, we get to it through the name of an object. Now, of course, we're not going to usually get to an iterator manually. We just use it inside loops like this implicitly. Now, inner classes are especially great for grouping related tests in a JUnit 5 test suite. So for JUnit to do this, we just have to add an annotation called @nested. And keep in mind, that's a JUnit annotation, not a Kotlin annotation. So don't get confused at the naming there. When we run this kind of a test, we'll get test results that are grouped according to the nesting that we had. And that can really make it much easier to understand as you look over the test results. Next up, we've got one of my favorites, which is data classes. As the name implies, data classes are great for storing data, especially immutable data. And when you use the data modifier on a class, it's going to automatically get an implementation of equals and hash code that will make it so that these objects are compared by value instead of being compared by reference. Also for data classes, Kotlin will implement a toString method for you so that you can print out the contents of the objects. And some Kotlin developers just love using data classes just for this feature even. Data classes can also be destructured. And when it does this, it will appear in the same order that the properties appear in the constructor. So we might want to, for example, extract the title and author properties into variables, and we could do it like this. And finally, since we most often use data classes with immutable objects, it also includes a function called copy. So instead of changing the data on the object itself and mutating the data in that object, Copy will create a copy of the object with the changes that you want applied. Data classes are great for any kind of simple carriers of data. I like using them for data transfer objects, intermediate data types when processing collections, and most types that just need to be compared by value. Next up, we've got value classes. A value class can be a great choice when you want to wrap a simple type with a strong domain model. So for example, a lot of times when you've got a function that has multiple string parameters next to each other, it's easy to get the arguments mixed up like I did here. We could help to mitigate this by introducing a class for each one of these parameters like this. And this is a reasonable approach for small sets of data, but if we were processing a large batch of books from a file or a database, we would start taking a hit on performance because instantiating each book is going to require allocating space on the heap, not just for the books and the strings, but also for the ID, the title, and the author of each one. So instead, we can turn these into value classes, which if we're targeting the JVM also requires us to add this @JVM inline annotation for now. By changing these to value classes, Kotlin can optimize them so that their runtime performance is basically going to be roughly the same as if they were the underlying integer or string types. Now, a value class has got to include exactly one property, and it has to be read-only, so you have to declare it with val. And value classes are especially powerful when they're used with JVM primitive types because the primitive types go on the stack instead of on the heap. So again, use value classes to wrap a simple value with a strong type, which will improve type safety, usually without the overhead of the additional object allocation. Now let's look at enum classes. All of the instances of an enum class are contained within the body of the enum class. Each instance is called an entry of the enum class. And enum classes are great for limiting the values that pertain to a type, like each status that an order might have. And we can reference an entry by using a dot after the name of the class like this. We can iterate over the entries, and each entry has a property for its ordinal and for its name. Now, one of the neat things about an enum class in Kotlin is that they can be exhaustively matched in a when expression so that you know when you've included all of the entries. So again, enum classes are great for limiting the number of instances of a class to a set of known values. Now, if you need to limit the subtypes of a class rather than the instances of a class, you should consider a sealed class. With a sealed class, you'll often see its subclasses nested inside the sealed class like this. But they don't have to be, as long as they're in the same module and the same package. These limitations allow Kotlin to take inventory of all of the direct subclasses of a sealed class so that they can be exhaustively checked in a when expression. That way you know when you've accounted for each one of them. Sealed classes are great for managing different conditions that all include their own data. And a lot of apps, especially on Android, will model their API calls with a sealed class so that you've got a different subclass for each kind of a state for getting the data from the API. So you've got one that would be success, one that would be error, and one that would be in progress. So a sealed class is a great choice when you want to constrain the direct subtypes to a set of known types. Finally, let's look at annotation classes. I'm sure you've used annotations like @nested or @JVM inline like we used earlier in this video. Well, if you've ever wanted to create your own annotation, you can do that too. At its simplest, you just use the annotation modifier when you declare a class like this. But you'll also typically want to use one or more annotations on the annotation class. And when you do this, these are called meta annotations. You can use meta annotations to indicate a variety of things about this, like what kind of elements this annotation is going to apply to, whether it's available at runtime, whether it can appear more than once on the same element. Now, generally, most application developers are probably not going to need to create their own annotation classes, but they can be helpful if you're building out a framework or a tool that needs them either at runtime via reflection or at compile time via a compiler plugin. So if you're an application developer, you'll probably use annotations, but you won't often create annotation classes yourself. But if you need to, they're available for you. So that's a roundup of all the different kinds of classes as of Kotlin 1.9. If you find yourself getting a little bit lost in the different features of these different kinds of classes, it's okay. I will be sending out next week to my email newsletter subscribers a cheat sheet that includes all the different features from the different class types that we covered in this video. So if you're not already on that list, be sure to sign up at newsletter.typealias.com. Thanks again to Superhuman Dose for requesting this video, and thanks to you for watching it. I'll see you next time. You've read the chapters online, and now I'm proud to present the Lean Puff edition of Kotlin, an illustrated guide. Take the book offline with you, mark it up in your favorite PDF software, and get early access to new chapters as they're written. You can pick up your copy today. Just go to book.typealias.com.